Hello, my darlings. Today we are going to look at how to find the inverse of a 2 by 2 square matrix. So you can see the formula up here. A inverse equals 1 divided by the determinant of A, and then the down diagonal flip-flops and the up diagonal both change signs. But one thing to keep in mind, inverses only exist for square matrices where the determinant does not equal 0, because obviously we can't divide by 0. Dividing by 0 is undefined. So our first example here, first thing I want to do is find the determinant. So down diagonal minus the up diagonal gives me 13. So then I plug into the formula 1 over 13. The down diagonal, the 1 and the 7, flip places. The up diagonal, the 2 and the 3, change signs. And then I just distribute the 1 over 13, and my inverse is 7/13, 2/13, negative 3/13, 1/13. So again, another one, down diagonal minus the up diagonal. So 14 minus 12 gives us a determinant of 2. So the inverse is 1 over the determinant. The down diagonal flip places. The up diagonal change signs. Then I just distribute the 1/2, so we get negative 1, negative 2, negative 3/2, negative 7/2. And the determinant is very helpful when we look at it with what's called the identity matrix. It's like multiplying by the number 1, but it's the number 1 in matrix form. So any matrix times the identity is just that matrix. But here's the real helpful part. Any matrix times its inverse will equal the identity matrix, and that's what we're going to be using so that we can solve equations. Today we're not solving equations, we're just practicing with inverses. So example 2, find the value of k such that b is A inverse. Well, I'm going to use this fact right here, that if I multiply A times its inverse, it's going to give me the identity matrix. So I copied the A matrix and the B matrix, and then I'm using matrix multiplication. If I multiply the second row times the first column, I know that it's supposed to equal 0. So I'm using row 2, column 1. So if I go across the second row and down the first column and do my dot product, I get negative 2/3 plus k equals 0, so k equals 2/3. So let's try that again. If I multiply A times B, it will give me the identity matrix. So this time I decided to use row 2 and column 2. So row 2 and column 2. So going across row 2 and down column 2, I'm supposed to get the identity matrix, and in the identity matrix that would be the number 1. So doing my dot products, I end up with 0 plus 2k equals 1, so k equals 1/2. All right, have a great day, guys. Bye.